Awesome.
Okay.
Yeah, thank you everyone for joining. We are looking forward to hearing a bit more about SolarMD's new outdoor cabinet, really changing some stuff up there. Thank you for everyone who submitted their points of interest. I think this is definitely the way to go for future webinars as well. So please make sure to utilize that tool when you RSVP for any webinars that's coming up, and letting us know what you expect from the webinar in advance, and we can make sure to meet those expectations. So yeah, just thank you from IBC side again in advance, Alex, for presenting. And with that, I will give this over to you. Thank you.
Thank you. Let me quickly set up here, get my screens straight, and then I'm with you just now. 1 second.
Perfect, no problem.
Okay, I'm sharing my screen now. Let me know if it's coming up.
Yes, we can see it. Thanks.
Perfect. Laser pointer also, everything here? Yeah.
Yes, all good.
Perfect. Okay. Yeah, thanks. Welcome, everyone. Sorry for the little delay. Took a moment to lock in, but let's hope that everyone else also is going to be able to join. Do I see some familiar face? Oh, I see Omid in here. Omid, long time, very long time that we have spoken. I hope you're well. See a lot of IBC guys. I see Solar World as well. I see Sean here. Nice. And Anton, hey, how are you? Okay, awesome, good to see a couple of familiar faces. Let's kick it off. All right, I'm gonna start with we're gonna go from like the start of high voltage, like we start a little bit with the high voltage battery, and our high voltage new 16 kilowatt hour module, and then go from there into the outdoor cabinet, and then also into the work modes of the outdoor cabinet, so that we can go really from the start to the end of the high voltage kind of like products, because obviously our high voltage rack mounting system or like rack battery is also the same one we use in the outdoor cabinet. So I thought it's a good start to start there from the beginning, and explain a little bit about the installation of it, and then we move into the outdoor cabinet, because it's exact same mounting way and commissioning way, how to do it in the outdoor storage cabinet. So let's start with the high voltage side. All right, cool. If anyone has any questions, please raise your hand. I think I can't raise my hand here on my one. I'm not sure, Zena, if raising the hand is disabled or anything like that.
No, they should be able to, but everyone is muted. Would you like an open conversation and I can allow mic, or would you like to use the chat?
Yeah, the chat is good. The chat is good. I can disable a mic then if someone writes something, and I can interact with everyone. Yeah, I can disable the mics here as well. Okay, perfect. Yeah, just write into the chat if you have any questions. I have it open here on the left side of my screen, so I can see it. All right, perfect. Okay, let's go. Okay, yeah, actually, the very first thing is I want to just very briefly go into our new battery range, just to give that a brief reminder to everyone that we had a change in our battery. And the change is that we changed from a 280 amp hour battery cell to a 314 amp hour cell. It's still CATL. We're still using the CATL cells. The only thing what changes is that we now have 10% more capacity in the battery. So same size, and the cycle performance from 6,000 cycles up to 7,000 cycles. And our max charge power went from 1C to 0.5C. So for 2-hour systems, which is 99% of the use case anyway. So just to summarize that, so the 16 kilowatt hour capacity is exactly in the same size as what it was before. Same look, just more inside, right? And this is throughout the whole range. It's changed from 14.3 to 16 kilowatt hours. And so we have 10% more capacity. We have extended lifetime with 7,000 cycles. And this means with more capacity in the same housing for kind of like for lower cost on the product build, we have a lower cost per kilowatt hour. So we were able to, with this change, to have more capacity in the battery and a lower price per kilowatt hour in a whole battery. And obviously with that also a higher throughput guarantee with 84 megawatt hours of energy throughput guarantee. Before it was 60 megawatt hours, so we have 24 megawatt hours more capacity we can now use in a battery, which we guarantee. All right, let's go into the high voltage products. If we speak about high voltage products, we start with our lowest module or lowest increment. That is our SS6160, which was 6143 before, and now 6160, which is our battery module. That battery module then gets combined into a SS70XX, so various ranges of full batteries, and they range from 80 kilowatt hours up to 272 kilowatt hours. The battery module itself, it's as nominal voltage of 51.2 volt, and combined in total the voltage range with 17 modules, the total it's 870 volt. So we need to always look for that if we looking at high voltage systems, and obviously also choosing a battery inverter. We need to check the battery voltage. I have a little calculation in this presentation as well, where we calculate and see the differences of high voltage systems. So now the SS6160, 16 kilowatt hour energy in the same housing, infinite scalable, so you can parallel as many as you want, more or less. Obviously at one stage there will be a limit, but that limit is more about how many hours you discharge rather than actually the battery itself. So high energy use and distributor friendly product. If we look into more detail, we said what I said earlier already, still battery manufacturer, the cell manufacturer is still CATL, 16 kilowatt hours of rated capacity. Then nominal power at 0.5C now, it's 8 kilowatt. Nominal voltage, 51.2. Operational voltage, 44.8 to 55.6. And the max charge and discharge current is 157 amps, right? So which is a bit different to what it was before. Before we had 200 amps here, charge and discharge current, but now it's a bit lower. It is 157 amps. So we just need to be careful in designing our systems. Also with the 14.3, the 16 kilowatt hour wall mount residential product, it's the exact same. So just be careful with that. If you parallel that with any inverter, with your with your Victrons or anything like that, just make sure that the charge and discharge current matches your inverter. Okay, if we speak about high voltage batteries, we always speak about the SS70XX batteries. So we know one battery module is just one little increment of a full battery. Then we have the BMU on the top left. We have our frame system with different sizes. We have our BMS, which is in front of each of single batteries, and then our protection as well as connection elements. We're going to have now a deeper look into all the little parts here. Let's start and have a look at the SS61. Oh, here's still 43. It's wrong. Sorry, I need to change this in the presentation. It's obviously SS6160. If we look into it a little bit more in detail, each battery module has got, so now it's lagging a bit. Oh yeah, that's going in. Each battery module has its own fuse protection here, which is a 1000-volt fuse and 250 amps. Each module will have its own BMS, so we can see within to each of the batteries, each cell detail, the voltage of each cell, and different temperature measuring points, which we have got inside each of the batteries. The bottom right, we have the DC connection points, and on the left side, we have our CAN bus connectors. If we're now going to look even a little bit more into detail, the BMS in the front, but if we still look into the BMS at the front, we have got the cell harness connectors at the top. We have got our relay connection at the top. We have got some external temperature sensors, which are not necessarily needed. The right side here is our push button connected. And very important, one of the most important functions on the BMS is the on and off switch, because each battery comes delivered in off position. So you can see it pretty easily here. Off position is on the left side. And very important is if you want to switch on a battery before you press the button of the battery or the button of the BMU, you must switch on the battery. But I have a little bit of the startup procedures also in this presentation. We have some status LEDs on the right side here. We can see the status, warning, error, and see if something is wrong. Then we have at the bottom here a capacity indication, which is from 1 to 6. And you can see actually it's written on it, 0% is on the left side and 100% is on the right side. So you'll see the lights going up to the right. If the battery, what the state of charge of the battery is. And we can see if it's going one direction, if it's discharging or charging, as well as some other functions for these LEDs. Also important at the bottom here are termination resistors. They're also quite important because the setting of those are important for the communication, and it's important they set into the right directions. I'll have some infos on that in a bit. The bottom here is our CAN bus communication. On the high voltage battery, they're already connected. They're already connected to the metal frame of the high voltage battery. And then from there, you connect up. So you don't have to do the connection on the BMS itself, but you do your CAN bus connection from the front of the high voltage battery. Also important, here you'll see your serial number. It's gray at the moment because there's no sticker on it. It was a new one. And as well as the hardware version and the product code of this BMS. But you can also see, for instance, in the bottom right here, version 3.06, and you see the same codes also here on the hardware and product code that when something happens or anything like that, you can always let us know what hardware version you have got, and then we also know exactly what kind of like BMS you have. Then if we look at the BMU, which sits on the top left of the battery. We have the service port here, which is just for internal use. Here we have the Ethernet port, which is important to connect the BMU to your Ethernet hub or to your logger. And then we have two communication ports here. One communication port, the top one here, it's two different connections. It's either a CAN bus for external communication or it's RS485. Depends what we connect to. And this is the internal communication at the bottom, which is CAN bus 1 and CAN bus 2 for internal communication. On the right side, on the top, we have got our high voltage connection, where this is our connection towards the inverter or the outside or wherever we connect to, our positive and negative. And on the right side here, it's our positive and negative connecting to the high voltage batteries underneath the BMU. And in the middle, the mechanical isolator, also very important. It's always on, it's the last kind of like thing you switch on, because that is the connection between the battery and the inverter or whatever is connected to it. So the mechanical isolator is always the last thing of protection in a way, manual protection, where you can switch on, switch off the whole battery stack. If we look into a little more detail into the BMU, now we're looking on it from the top. We can see on the bottom here, that's our mechanical isolator connected to the outside here. Then the high voltage connection points for the inverter we saw already. The right side, which was before the left side, now it's the right side, is the communication PCBs. So we can see the communication PCBs on the right side here, and in the middle is our main power PCB, right? And on the left side, we can see the fuse. This is also 200 amp. It's a 200 amp fuse, 1000 volt, 200 amp fuse, and our main relay as well as our pre-charge circuit relay, and the shunt up here to count the energy going in and out of the whole battery stack. Now we will look at the last part of our battery, high voltage battery system, which is the battery frame. The battery frame comes in 3 different sizes. We have an 8-way frame, which is one rack only, 1 rack and 8 slots, but it's for 7 batteries on 1 BMU always. So 8-way cabinets, you can H8, so it has high, or like the heights of 8 slots. And R1 is just like 1 row of it. You can see 7 batteries and 1 BMU. And then we have our H6, which is a 6-way cabinet, but it's 2 of them. It's 2 6-way cabinets next to each other. And this, it has obviously like 2 times 6 has 12 slots, but we're only using 11 for the battery and 1 for the BMU. And then our biggest one is 2 times 9-way cabinet. Or rack, and this is then 17 batteries and 1 BMU. So these are the single components of a high voltage battery system. If we build those high voltage battery systems, we can parallel them, of course. So we have the possibility to have a single rack and then multiple of the single racks. Important is just that we have the same amount of batteries in each, as well as the double stack batteries, or the double row batteries, also with multiple. And if they're not even fully filled up, you can obviously later on extend them and add more batteries to it. Just if you have a multiple stack battery, then you need to add, if you want to extend those, you need to add, let's for instance on the picture here, you need to add 3 batteries, 1, 2, 3, 1 per rack. So it's very important that you always have the same amount of batteries. If we look into the range of it, the range we have, at the start, we're starting at the lowest, it's the SS7008, which is 80 kilowatt hours and 40 kilowatt output. And then the SS7013 is in the middle, more or less, 128 kilowatt hours. And our biggest one with 17 modules is 272 kilowatt hours. And at 0.5 C, which is exactly half of it, that's the output power. Very important to know that, as well as the operational voltage of this battery system. Very important. We'll go into a bit more detail on that in the next slides. Now, just one quick information on how the racking system is transported. So it comes in these wooden crates. So it comes flat packed and is stackable for transport, for ease of transport. And you have everything inside. All your comms and DC cables are inside, as well as some blanking plates if you don't use all the slots. And of course, a packing list and some information on how to build it up. And you can build it up yourself. The shelving makes it for transport much easier. And yeah, and then you can just slot the batteries in. If we look at a little quick example pictures, this is a system built into a room. This is actually at Tokara in Cape Town. So multiple batteries here. So, and the inverters are also, this is not a containerized solution, anything like that. The client bought the Kuhuatech inverters as well as the batteries themselves, and installed everything themselves into this room and built their own kind of like battery room. Okay, any questions so far till here? Okay, then I'll continue. All right, if we look at a quick installation information on the batteries. So the very first thing to do is assembly of the rack system, right, into to house the SS6160 and the BMU. So it's the very first thing you do. You're going to build up the racking system, and it's very easy. It's not too difficult. There's also some more information on how to exactly do it. Important is that you also always do the grounding of those. So it's a metal part, but that the battery in general is also grounded. So always make sure at the bottom you ground it. So just as a little marker for the installation of the racking system. Then the next steps is you put the BMU in. BMU slides in on the top left, and then on the right side you start, or below you start with the batteries and slot in the high voltage batteries. Important is make sure everything is still switched off. Slide in all the individual batteries, and then secure each module and BMU with the bolts and grounding washer, which is delivered with it. So secure them right away so they don't slip out or anything like that, or they fall down or anything. So make sure everything is secured. Then the next step would be to start with the communication wiring. Connect the Ethernet port of the BMU to the network switch. The Ethernet port we saw earlier is on the left side here, and you connect that to your network switch to get internet, or like get an internet connection to your BMU or to your network. And then you start from CAN bus 1, connect to the next battery. So we saw already earlier the BMS. Those little blue lines are already made from the BMS to the battery front panel. Those connections are already made. The blue ones, maybe have a look at them, see that they're all connected properly, but they're already made. So you just connect from CAN bus 1 down to each battery, and then all the way. And what very important is, for this communication, we actually do not need an end-of-line termination resistor. What you need to do is, as we said earlier, on the BMS itself, you can see the termination resistors are on the BMS. So what you do is the CAN bus 1 you turn on, the CAN bus 2 you turn off, and RS485 you turn on. Right, on each battery you do these settings to make sure they're all set correctly, and then check that, and then you switch on all the BMSs. So you tap that little switch to on, so that we can see, or that you have all BMSs switched on. So now they're ready for communication and ready to start up. Next step would be power cables. Here it's also very important, everything is delivered. So you have different cables. We can see this here pretty good. You only have one positive to positive cable, red and red, which is your first battery. And you have only one negative to negative cable, which is marked with black to black. All the other in-between cables between the modules go from negative to positive, negative to positive, negative to positive, right? And they're also marked that way. So you have black to red, black to red. So you can't really make anything wrong in connecting them. Oops. So just make sure the colors are all matching. That's the very important part. Also, if you do install any high voltage systems, please make sure you did our SolarMD level 1 safety training, which is very important to do that. So this training, if you need to do it or you want to do it, please let us know. You can also send into the chat here, send your email, or send an email address, or send an email to support at SolarMD, and then they will send you the training as well as the test, which needs to be done after the training, that you have done the safety safety training to install these batteries. We're working at much higher voltages, so it's quite important to make sure you have protective gear and we avoid any short circuits. All right, next step is connecting the logger V2. Now for each system, each high voltage system, different to the low voltage side, each high voltage system must have a logger, right? That's very important. You can connect it in a different way. So we know from the low voltage side, what we did often is we connected the logger to the battery directly as a power source. This time, please don't do that. This is not going to work because the voltage is far too high for the logger. So please do not do that. It needs an external power supply, which could be a USB-C or a direct connection from a DC source, but only one of them. Please don't connect two of them, only one of them. If not, that also creates a short circuit in the logger. So on the communication side, you have different ways to communicate. If you have one battery, you could generally connect it right away to the logger, and then the logger connects to the router either with cable or with Wi-Fi. But if you have multiple batteries, the best is to have a Ethernet switch here, which then you connect all of the logger as well as all the batteries to an Ethernet switch, and then the communication can happen through this Ethernet connection. And then from there, from the logger, you go to the router again, same way, via Wi-Fi or with the direct line. Now, last step of the commissioning or kind of like installation, it's a startup procedure. Very important is review all the connections you have done. Check again, check on your on the connection diagrams if you have done everything correctly. Is the right colors connected to the right colors? That we don't have a short circuit or anything like that. So that's quite important. And then what you can do is you can start with pressing the button, the green button on the top, hold it for 2 seconds, and then the BMU will turn on and will communicate with all the BMSs, and then we will be able to see that all BMSs are starting up and communicating. And if you see one BMS not communicating, then we can do some troubleshooting, but all BMS need to illuminate at this point. Once you see that, you can install all Perspex covers and secure the front, so you have a bit of a touch protection towards the battery, and can move from there. Once this is all done, please check again also your output cables to your inverters. Are they terminated anywhere? Are they still lying around, not connected? So making sure that we don't create a short circuit. And once you have checked that, then that's the last step, mechanical isolator. You push that down or pull that down, and the battery connects to the inverter, and your system is fully commissioned. Then we have to do still some setups on my Power 24, but I left that out for today. Okay, before we go to the outdoor cabinet now, I would like to quickly go into a design guide just to explain a little bit about designing the high voltage systems. And for that, I have got, I'll open it now in a compatibility matrix. Okay, let's have a look. So what we can see here in a compatibility matrix for the high voltage side is we can see 13 inverters, right? All the different brands which are compatible at the moment with our battery. Then if we use, for instance, let's have a look at the GoodV, because I have an example of the GoodV also. If we look at the GoodV ET, we can see the operating voltage of the GoodV ET is 200 to 800 volt, and the charge and discharge current is 100 amps. it's 2 outputs, which are 50 amps each, which can be paralleled to 1 output. So you have 100 amp of charge and discharge power. So what does that mean? Now, in this table, we have all our batteries listed up here. How many battery modules? How much kilowatt hour per battery system? The voltage. Actually, mistake there yesterday. I'll repair it right away. Perfect. Now it's correct. So now we know the nominal voltage of the battery, and our max charge and discharge current is 157 amps. And then we know with this battery has a maximum charge discharge power of 40 kilowatt. But it still fits from the voltage to any of these inverters, even though they might be bigger. So it's quite important is that we now see this has an output power of 40 kilowatt maximum, this battery, but on this inverter, on the good V50 or 25, we can do a maximum of 25 kilowatts. And what is the reason for that? Is because now we're having only a charge and discharge current of 100 amp, right? So you need to now see that the voltage, the 256 volt multiplied by 100 amps is only 25 kilowatt. And this is what you can see in this battery matrix here, the compatibility matrix that we have drawn up. So you can see, even though I'm using, let's say, let's say with the good V50, I only can use the full capacity of this inverter at this stage with this battery, right? So we need to be careful of what we use with high voltage. So it's quite important to know the voltage of the battery, the maximum charge and discharge current of the battery, as well as the same information from the inverter. So now if we go into, I will send this around so you can use it. It's quite a nice overview that you can then size your batteries and see how much energy or charge and discharge current you have got. If we now, if we now go into the calculations of this and explanation, what we can see is, okay, so we know our BMU has operating voltage of 250 to 1000 volt. Now, if we take the example of the SS7013, 128 kilowatt hours, we know we have 16 kilowatt hours per battery module. Our nominal voltage is 51.2 per battery module. Our max charge and discharge current is 157. So now we know that these connected together come to a total of 409 volt, right? So we just add, because it's a series connection, it's not parallel like the low voltage before. On the high voltage, we obviously have parallel series connection. So now we have 400 volt with 157 amps. If we now look into the calculations of that, now we take 8 times 16, so we have 8 battery modules, is 128 kilowatt hours, is our SS7013. Then we take 8 times 51.2, we have 409 volt. And now the 409 volt multiplied by 157 amps gives us a total of 64 kilowatt of maximum charge and discharge power. So this is what maximum the battery can give. If we now translate it into, or compare that with the inverter, let's take the good V50 for instance. The good V50 output power is actually 55 kilowatts maximum charge and discharge power, a little bit higher, 10% higher than what it says on the nameplate. And we have 100 amps charge and discharge power. So now we calculate take the example of the SS7008 with 256 volt, 100 multiplied by 100 amps is 25 kilowatt. So we can see that the output power with this inverter of the 80 kilowatt hour battery is only 25 kilowatt. Of the 176 kilowatt hour battery is only 56 kilowatt. So generally, if you want to have the full output power of this GoodWe 50 kilowatt inverter, you need to install 176 kilowatt hours of batteries, which sounds quite a lot. For this inverter, unfortunately, with the 50 kilowatt inverter, the 100 amps is a bit low, but also at the same time, you can use the 25 ET25, right? If you use the ET25, which also has got 100 amps, this one, you can use the 80 kilowatt hour battery and have 25 kilowatt output. There it fits actually. There it's not too bad. You don't have to have it too big of a battery. So even the 30 as well will work. ET30. So ET30 also has 100 amps. So always calculate your output power on the batteries in your inverter. All right. Did we have any questions that I didn't see the chat here anymore? Okay. That was the first part. From Omid. Yeah, Omid, I'll check for you quickly. We can just have a look. Yes, the Sunsync 25, probably. Yeah, it should be. But I think I need to look it up. Omid, I will send you a mail. I'll let you know. But from protocol and communication, it's not a problem. It definitely should work. It works with all the other ones, so it should be no problem. We just need to check the charge and discharge currents and then match it with the respective battery, and then it should be no problem. All right, let's jump into our auto cabinet. All right, a little bit of a new design. It's changed a little bit from last time. So our auto cabinet, we think and we call it the most flexible solution, because it's flexible. It hasn't got an inverter included. It's adjustable with any inverter we are compatible with. So any inverter can be mounted to it. It's lightweight design, 150 kilogram. So because it comes without any battery inside, we deliver the battery extra on a separate pallet, which makes it a bit easier to transport. You can use the pallet jack to actually transport it anywhere. Makes it much more easier for you to, any remote sites. You don't need a forklift, or you don't need any heavy machinery to lift in a ton or 2 tons of batteries or anything like that. So it all comes in its separate parts, and the auto cabinet comes just like that, built up, of course. I see now Anton wrote, according to Sunsync size, the 25 is covered. Okay, perfect. Yes, yeah, I was sure the Sunsync is also compatible. I was pretty sure about that. Yeah, thank you. Oops, back to this. So yeah, it comes built up completely like that, and you just have to slot in the BMU and the batteries and all of that. We have built-in fire protection, integrated cooling system, and it's compatible with all major brands. And what we fit in here is 80 kilowatt hours is your minimum, up to 272 kilowatt hour maximum. So 17 batteries. Same, it's exactly, so the racking system, everything inside is exactly the same what I explained earlier. So it's still the high voltage system. It's the same battery we're using. It's still the SS6160. And we're using the same BMU, it's same BMS, and the metal frame, it's the same, just built into this IP65 housing. So we're using here CATL cells, same like before. So nothing changes. Operating voltage is also the same, exactly the same as on the high voltage system, 7,000 cycles. There's obviously a thermal insulation, which we are using. It's IP65, so, and an air conditioning. So everything else is exactly the same, like we have on our high voltage battery, which we saw earlier, which just without housing, which you can build into a room. Now it's just got a mini, like a small mini container, let's say, which you can purchase separately. What are the features of this outdoor storage solution? It's obviously our SS70XX is inside, right? BMU sits on top here. You can add on modules, same like you know from the high voltage system. We have mounting plates on the side where you can mount equipment, where you can mount your inverter, your GoodWe, your SunSync, your whatever inverter you can mount to the side. The battery frame, it's exactly the battery frame what I explained earlier. It's built in here. Fire safety, cooling system, and then also on top of that, we have got add-on products. Our add-on products, we have a PCS. So here we're going to talk about this a little bit more in the next slides. We have a 125 kilowatt PCS, which you can connect to it, an STS, static transfer switch, and an MPPT. So you can make this a full hybrid system just from kind of like our equipment. If we open it now and have a little bit more detailed look, so even though we do not load it completely and you can install it with a pallet jack or transport with a pallet jack, we still have eyelets on top. So there is like you can screw in eyelets on the top and you can still lift it in if you would want to, if you want to lift it in somewhere. So it has that stability and also the lifting points if need be, or you have installed it and you want to put it somewhere else or anything like that. So you can pre-commission it, for instance, install the inverter on the side and everything, and then lift it into its place if needed. The top left side is the DC connection box. Top right here on the picture is our BMU. Normally have it on the left side. Not sure why it's drawn here on this side, but the BMU definitely needs to be on the top. And our connection box is here where it connects to. Then we have in the door, the aircon is installed into the door. Then on the left side here, we have our panel for the AC breaker, for the logger is built in here. Fire suppression is installed here, as well as the Ethernet switch is installed on that side. At the bottom, now you can't really see it on this picture, but these are just little plates in front of the actual footing. The footing is made for a forklift or a pallet jack to drive in. So these are just little visual plates which sit in front of it just to make it look a bit nicer. But it comes without them, they're not screwed on when it gets delivered. They're inside, so you screw them on later, and then it's just a normal transport footing like a pallet. If we now turn it around, we can see on this side here, there is a connection box, which is covered so that it can't get wet or anything like that. If we open it on the left side, we have a 230 volt AC connection port or connection block where you need to connect AC. So the aircon and all of that is not going to run from or needs external AC power, as well as the Ethernet, the logger and all of that. It needs external AC power. If you're in an off-grid situation, obviously this power you install an inverter outside here, that power would obviously then come from your inverter. But normally it'd be the better way to have, or like your backup circuits in a factory or anything like that, you would connect it to that and not directly into the circuit of the battery. So it will be going to the loads. It's a load connection, so that the aircon and all of that is a load. Then we have got next to it in the middle of the connection box, we have our network connection points where you have Ethernet points connected to the switch, where you can bring in the Ethernet or internet from the outside, as well as your inverter, your GoodWe inverter or anything like that can connect here with CAN connection points, as well as Ethernet connection points. So it will be able to connect on these ports to the batteries, to the CAN port, to the Ethernet and logger inside the auto storage solution. Then on the right side of it, we have got 4 DC connection points, 4 times positive and negative, of course, where you can connect your inverter to it or your MPPT. It depends. This all goes onto the same DC bus bar inside and then connects to the batteries. So you have multiple possibilities to connect outside. Then we have got mounting brackets, right, which can be installed into this frame. And these mounting brackets you can put wherever you want on the height. You can vary the heights where you put it, and you can mount your inverter to it. So you can mount the inverter on this side, also on the other side. So on both sides it's possible. And you can mount 1 or 2 inverters, or you put one of your hybrid inverters and maybe if it's off-grid side, like a little AC connection box. We had someone inquiring for like a pump, for instance, in the middle of nowhere, like on a farm with no AC, nothing, an off-grid system. So you put a little AC distribution board down here and then connect that to your pump or anything like that. So you have possibilities to mount things outside of this housing, and it really stands on its own and can be a bit of your mounting spot for the things you need. All right, we have some kind of like bundles which we offer with it, which they can be connected right away. So standalone, that's just the battery standalone by itself, where we can have 80 to 272 kilowatt hours, and you connect whichever hybrid inverter is compatible to it. Then we also have the possibility to use our internal PCSs. We have 100 kilowatt or 125 kilowatt PCS, which we can use for 2-hour systems, as well as SMA bundles with the SMA Sunny Island, where you can connect the SMA Sunny Island, the new Sunny Island 50 to it, and as well as a bundle. If you look into that a little bit more in detail, we can see the new SMA Sunny Island is for 12 pieces in parallel, so up to 600 kilowatts on-grid or off-grid. That doesn't matter. So there's no limitation of that, but 12 is the maximum for on-grid or off-grid operation of the Sunny Island. The Sunny Island, for instance, also, because it's a 50 kilowatt inverter, it's a bit small for the cabinet because we would need a little bit less battery actually for this. So what you can do is you can actually connect 2 inverters to it, which is possible. So you can connect 1 on each side, let's say, and then you can split, or 2 on one side, also possible. And then you can split the battery, put 2 BMUs on top, and have for each inverter 1 battery. Makes it a bit easier. Or if you have a 2-hour system, you would put only like 100 or 120 kilowatt hour battery on each side, and then put your 50 kilowatt inverter. You can do the same with your GoodWees or Dayas or anything like that, because if you use a 50 kilowatt inverter, you maybe don't, you only want to put 100 or 120 kilowatt hour of battery. So you can still parallel those, have 1 cabinet, 2 paralleled systems with 2 batteries inside, because obviously they need to have a battery. They don't work on a DC bus. They work on each string, or each inverter has its own battery. So you can separate those. Same thing, quick calculation we did earlier with the Sunny Island. Sunny Island has a charge and discharge current of 150 amps, which is a little bit higher than what we saw earlier from the GoodWe, for instance. So now you can choose a smaller battery to actually deliver 54.6 kilowatt. So now with this 150 amps, you can install a 112 kilowatt hour battery and can use the full capacity of the Sunny Island, right? So it's the same calculation what we had earlier is in this slide as well. So that's why the SS7011 will be enough for one sunny island to give the full output power of 50 kilowatt, right? So just be aware of that. So high charge and discharge currents up to 150 amps are very good for these smaller 50, 70, 80 kilowatt, 100 kilowatt hybrid inverters. Oops, this was a bit fast. Now coming to our in-house bundles. So this is still the old picture here of the previous version of the outdoor solution. So here, the SolarMD bundles, we use Yund, which is a Chinese manufacturer of PCSs, MPPTs, static transfer switches. And what we can do here is we can parallel up to 8 in off-grid environment, which means we can have 8 systems up to a 1 megawatt and 2 megawatt hours just in outdoor storage solutions. It will fit exactly the same way with this housing. It will fit the same way onto the new one, same like you see on the picture to the previous version. It's just we just had some internal changes on the wiring. That's why it changed. And on-grid operation up to 4 megawatts, 32 pieces in parallel. And what you can do, for instance, is have the PCS on this side, right? And we have the MPPT here, or other way around. Other way around would have been better. Sorry, other way around is actually much better. Just from the AC and DC side, but it's fine. And then the STS on the bottom here. And then you can connect, and then you have a full hybrid solution in one system with 125 kilowatt PCS, 120 kilowatt MPPT, so it's 2 times 60 kilowatts, and 250 kilowatt static transfer switch with a 10 millisecond changeover time. So quite a nice solution. If we now go to the next slide, the Yund PCS, it's a rack mounted PCS. So what we do is we put a housing around it, so it's going to be IP65 rated. So because this is only IP21, so only for indoor operation, but we're gonna put a housing around it and filters and all of that, so that there are no dust and water can come in. And we make this product IP65 and connect it outside to the solution. And then you have 125 kilowatt PCS. It's transformerless, but it has 3 wires plus N plus PE, of course. So, and 400 volt output. So you don't need a transformer for this. If you use this in a normal, let's say, residential settings or smaller commercial settings, just be wary if you don't install a transformer. We can also have multiple in parallel. So you can have 2, 3, 4 in parallel without a transformer connected to it. But obviously, without transformer, we need to be wary. If we have very extreme unbalanced loads and high startup currents on certain phases, this will damage the PCS long term, because obviously the transformer balances out the phases, and this in this way brings a much more equal draw from the PCS. But if we have unbalanced loads and they're very high with very high startup currents on a single phase startup currents on a 3-phase system, then this will damage the PCS. So you can run it without transformer, but just make sure it's a very balanced system and we don't have any high inductive loads or anything like that starting up on that system. If we do that, please make sure you install a transformer for the harmonics of the whole system and to make sure for longevity of the PCS, right? That's quite important. But other than that, if you can take 2 or 3 of them and parallel them and don't need a transformer. So it's a very, very, very cost efficient solution. That's the calculation of the PCS, sorry. So what we also can do here is, as you can see, we can have multiple systems and then they're all connected to the loads, to the grid for arbitrage or whatever we need. So we can parallel multiple of the systems. That's the back of it. We can see the DC connection, then L1, L2, L3, as well as the neutral. So it has a neutral connection, which is important to build up a grid. Without a neutral, some PCSs don't have neutrals, so they need a transformer, but this PCS has a neutral, so it doesn't need the transformer necessarily, just as explained. So now here also the calculation again, like we did earlier for our systems here now with the 125 kilowatt PCS, we need a minimum of 256 kilowatt hours of battery. So nearly the biggest battery. So only 16 modules is the minimum we should run with this PCS, with 125 kilowatt PCS. But I mean, if you know the client only has 80, 90 or 100 kilowatt loads and not higher, you could obviously also do it a little bit lower just to save some cost, but then we must make sure he doesn't overload the system. If we look at the STS, why does it always say, everyone always asks the question, why does it say 250 kilowatt STS? You will see it always the same. All the manufacturer call it 250 kilowatt because this is this side main power supply coming from the grid is 250 kilowatt. If we now look, so now this means 125 kilowatt from the PCS side, 125 kilowatt on this side. And also it means 125 kilowatt. Let's take on the backup loads, right? So now if we look at the energy flows, right, why is it always so high? Let's do this in blue. Because if the PCS needs to charge the batteries, right? Our batteries are here. Here are our batteries behind the PCS. So in worst case, we're charging the batteries with 125 kilowatt full power, and the loads are also drawing 125 kilowatt. So we have 125 here. This is going to be beautiful. And we have 125 here, right? And that makes total of 250. Right, so that's why it always says 250 kilowatt on an STS or like the changeover switches. And you can see also these are the grid connection points. They have much bigger connectors than the other two connection points for loads and your PCS, right? But this 250 kilowatt PCS is only made for 125 kilowatt PCS and 125 kilowatt loads, right? Just to everyone to understand this. Then now if we have multiple, as we said earlier, so now if we're using multiple products or building bigger systems, especially with STSs, then we're going to need a transformer. Also important is we can do up to 2 STS maximum of 2. We can do without transformer and with still 10 milliseconds. 10 milliseconds. If we add more, it's not synchron anymore. The changeover is not synchron. So we're going to, as soon as we do more switching with the STS, we're going to need the transformer for the harmonics, as well as the switching time will be higher than 10 milliseconds because these multiple products can't be switching in that very short time, super fast, under 10 milliseconds, doing exactly the same thing, and then synchronizing the grid at the exactly same time. There's just a communication delay, and that will definitely not be 10 milliseconds anymore. It will be a couple of seconds, maybe 10, 20 seconds or something like that, until they're all closed and everything communicates together and builds up a grid again. But then it can generally build up a grid. Up to 8 PCSs can run in off-grid mode. So then you also, instead of using STSs, could use any changeover switch, right? You have got, which takes a bit longer, same like you switch over to your generator, exact same thing. You switch over to your PCSs or you switch off the grid supply, and then you restart the PCSs, 8 of them, to create an off-grid system with 8 PCSs maximum. Just a quick view on to the MPPT. The MPPT has got 4 inputs. So it's 4 times 15 kilowatts, but it's only 1 MPPT, right? So just make sure that 60 kilowatt is must be one direction. So it can't be 4 different directions or anything like that. It's not 4 MPPTs, it's 1 MPPT with 4 inputs of 15 kilowatt each, right? Okay, if we go quickly to the work modes, these are the last couple of slides for today. If we go to the work modes, then I'm going to do a little bit more explanation. This is going to be quite important. So everyone who fell asleep, maybe listen again. Okay. Oh, there was a question from Anton. What is the warranty of the unit, the mass? And okay, they're all 10 years of all the products. If you buy them from us, they're 10 years. We give them with 10-year warranty. Okay, let's look into the work modes. Grid parallel, very easy, right? Having one PCS and battery, just grid parallel, very easy at this moment. If the it's another question coming here. What makes the ST? Who makes? What's Yunt? Yes, all Yunt. The PCS, the STS, and the MPPT. They're all Yunt products. Okay, so now if we look into our work modes, grid parallel, very easy. I think everyone knows this one. 0 feed-in we can do peak shaving, energy arbitrage, and increased self-consumption, right? So in this case, if the power goes off, the battery system also goes off, right? Because it's just installed grid parallel, and we have no switching elements in here. Next one we do, obviously we can do it's also integrated PV. So we can connect the PV side or control the PV with our logger. So everything is controlled with our system. Normally any grid PV inverter can be connected. And now if we go into, we put a switching element at the front. Now we're having, it could be an STS, could be anything for 20 millisecond switch over time. We could add this here, could switch between grid, between generator, also just to switch off the grid from it without generator. That doesn't matter. So now we have a full backup system in this case. So, but we're still working in grid parallel. So, right, this is pretty easy. We can very easy have let's say Yunt PCS here. We could put a Yunt MPPT here, and then this could be an STS, even though the STS now doesn't obviously connect this, right? So with this system for the outdoor storage solution, we can exactly build this, disconnect from the grid, and have PV connected right away and our PCS. Now, more important even. So now if we have multiple systems, so this is for one system, it will work with the 10 milliseconds. But now you say, hey, I have a 500 kilowatt system normally, or like let's say 250 or 350, anything like that, or 375. Then what we can do is we can work in our double conversion mode. So now, very important, if you want, so our double conversion, I think most of the people know it already because it's something we do quite a lot. Normally you have bigger PCSs. We have our 500 kilowatt Kehuas or 1 megawatt inverters, PCSs here. These are all big containerized systems, right? But okay, how do we translate this now into our smaller systems? And we give UPS style support as well as we do load stabilization. What we're going to do now is we're going to put, and this is now we can still think of outdoor cabinet, right? We're still in an outdoor storage solution. So we put a unit here. Okay, we put one here, output side, runs in off-grid. And we put one on this side. which runs on grid side. Beautiful writing here. Right, and now what we see with this is that there is no connection between the AC side. This is our double conversion system where this side here is DC. Right, this is our DC side. So both connect to the DC bus of the battery. We can obviously add PV inverters on the load side or MPPTs as well, same like we had just now as well. Very easy. So we can add MPPTs on this side, or we can just have PV inverters on the AC load side, of course. And then where are we now? Okay, yeah, different color here. Let's take this one again. So this is now our AC loads, right? Not connected at all to our AC in, or even the generator could also be here. If there is an ATS, the ATS can still stay and switch between those two if this is already existent. So now we have our AC grid side, the grid side AC, and load side AC is not connected at all with each other. What does that mean? We have disconnected this completely. So we have no grid instability issues where phases drop or whatsoever. We build an off-grid system here with the unit PCS. And what we can do now with this system is obviously what we saw now earlier, we can have multiple of those, right? Why don't we could put 4 here and 4 here, right? And then 4 here. So we do 4 systems and 4 complete outdoor storage solutions next to each other, and they all run in the same mode and then supply the loads. And then we put also more PV there. So we completely supply with this outdoor storage solution very easily, not containerized, which you can buy from IBC off the shelf, kind of like, and it doesn't have to be containerized. So anything under 1 megawatt can now very easily be supplied with multiple units in a UPS and load stabilization way, right away, kind of like plug and play, right? Not always plug and play. Something needs to be connected, but it's one of the solutions which we now have for like smaller systems and which works pretty well. So I think that's kind of like the highlights of the outdoor storage solutions, to have it like in a small way, now available at the distributor, very easily for an installer for small commercial systems to be installed. Just always make sure, just one marker I want to do. Let's use green. If if the system is a commercial system, right, we have a factory here and we have very unbalanced loads and all of that, please make sure that we put a transformer here. Yeah, not so easy transformer, but this should be a transformer. I hope this is pretty clear, right? To put a transformer here only on the output side to make sure that we have got a nice grid, right? And it doesn't damage the PCS too much. Wessel, good question. So no more Winline chargers for double conversion. Yes, you can use them as well. They theoretically would work also, but remember Winline. So now with this system, which is a bit smarter for the small solutions, let's say, it depends. There's 2 use cases. We would use the one or the other. Okay, so the unit, for instance, can feed back, right? We would also be able now to send energy back if that is needed. So if the client wants, it's yellow. Can't see yellow. Oh, what is this? Orange maybe. So we can feed back from here to here, right, to the grid. So we will able to feed back completely with the unit because it's a 2-way conversion possibility. Then, and we need to see what the spread is of the voltage. And with the wind line can't feed back into the grid. Wind line is only consuming. Wind line can only, if we use wind line on this side here for charging, then we can only feed back. Yes, unit also is NRS certified. Yes. So we can only charge the batteries with the wind line. But the wind line, the one very good thing the wind line has is if you have got a very dirty grid where the voltage goes down to 160 whatever volt, the wind line don't care. So if you like at the moment for instance, let's say in Tanzania, we have quite a couple of projects where the grid is very, very bad. And the wind line chargers are very good. They can go down to 120 volt, I think, on the voltage, and they're still gonna use the full power for charging. Where the unit, we haven't tested it in that environment, and it might not be as open to that, but that's the main reason, or that's the distinguishing we do at the moment for the wind line charger, right? But we have also a lot of new projects where, I mean, with the energy market opening next year, a lot will happen. So you might want the possibility to also feed back into the grid. So it's good to have the unit on the charging and discharging side. And yeah, also cost-wise, you're actually not going to be much difference to the wind line chargers. So it's more or less very similar. I think it's actually the unit is a little bit cheaper actually. Compared to the yeah, more or less the same price. More or less the same price. 3 of them and 1 unit. Yeah. Okay, I think this was quite an important slide to understand now the whole outdoor storage solutions with the work modes. Another work mode is double conversion, then increased capacity. So we could also increase the capacity if we do double output and only 1 input. But then we must make sure that we have enough PV to support that. If there's not enough PV to support that and charge the battery, the system will collapse and won't work and can't deliver more power than what actually can come from the grid, right? So that for information. Off-grid mode, I don't think we have to go too much into this work mode. I think this is pretty clear and pretty easy. Off-grid mode is yeah, very natural to everything. This was it. Oh, there's a monitoring slides, but I'm not gonna. We build a little bit over the hour now already. Took us the first 10 minutes to actually get everyone online, and now I'm 10 minutes over the time, so I will not go much more into detail of the monitoring, but I think every one of you, most of you know it. I mean, our compatibility is very important, so always check compatibility with the inverters. And as we learned now, please make sure to check the charge and discharge currents of the inverters, the battery, as well as the nominal voltages of the battery, that we know we have enough output power to supply the loads of the inverter. All right, then I'll quickly have a look into questions. If anyone has anything. Yeah.
I actually scheduled the call until 12:30, so you have 10 minutes for questions.
Oh, really?
So no rush.
Okay.
And then there is a couple more questions in the chat, but I've also, everyone should be able to unmute themselves if you want to ask a question instead of using the chat.
We can also do that, but then please raise your hand first before everyone gets to chatting, and then we can open it. So unit can feedback. Does it have? Yeah, it's NRS. We have NRS for the unit. Please also share NRS docs for. Yeah, okay. You don't have a LV wind line by any chance? No, we don't have. No, unfortunately, not for the LV side. No. What security locking system does the external cabinet use? And is there any option to add sensors at the door to alert an app to? That's actually a good question, Anton. Haven't thought about that. It's a normal rack, like your server rack latch, which clicks in and has a lock inside, like one of those like metal latches. But yeah, there's no door sensor. Maybe it's a good thing to think about that, actually. It's a good input. Thanks for that. Yeah. Okay, any other questions? No more questions. Want to have a quick look at this question we had earlier on the SunSync. And then
Alex, you're looking into something.
yeah, I'm going to put this here now.
Okay.
Because Omid asked earlier about the SunSync, the SunSync 25. Yeah, the only thing here now we need to check is the max charge and discharge current of this one is only 50 amps, so which is quite low. So just need to be careful of that when using our batteries if you want the full output power of 25 kilowatt. But other than that, it should definitely work. From a compatibility perspective, it should work. We just need to see that 50 amps only. So for 25 and 500 volts, then for that, it's 10 batteries. It's a bit much. So yeah, I think this is not really nice. It's not nicely going to work because you're going to need 10 batteries to run this at 25 kilowatt. And 10 batteries would be 160 kilowatt hours with a 25 kilowatt inverter. Unfortunately, not ideally sized. Yeah. Okay. Anyone, anything else? Any questions? Now is the time.
Looks like you gave a very informative presentation, Alex. All questions answered.
That's good.
So yeah,
That's good.
You guys are welcome to send through via email more questions. I will gather the data sheets as discussed in the chat, the presentation from Alex as well.
Yes.
That will be uploaded on our website, but I will also send through a link to the recording. So I will communicate that a bit later in the day. But yeah, thank you so much, Alex. I really appreciate a great webinar. Yeah, I think we've learned a lot, and we're looking forward to seeing many of these installed.
Yes.
So
Thanks,
yes, thank you
Thanks
so
for
much.
hosting.
Of course, anytime.
All right. Thanks, guys.
Thank you, everyone. Bye bye.
Chat soon. Bye bye.